In this video, I'm going to work through two problems in which we have to convert units that are raised to an integer power that is squared or cubed units. And I'm going to go through two different methods for converting. The first is going to be to find a conversion factor, a single conversion factor, for the squared or cubed units. The second is going to be just repeated use of a linear conversion factor. So let's get right into it. Our first example is convert 0.00640 grams per cubic meter to grams per cubic centimeter. And our process is going to be very similar to when we're converting just one unit. We need to figure out what units we're converting first. Here we're converting from cubic meters to cubic centimeters. That's the only unit that changes, so we need a conversion factor between them. However, I don't know the conversion between cubic meters and cubic centimeters. But I do know the conversion between centimeters and meters, so I'm going to start with that. So I'm going to start with my equation for cubic centimeters to cubic meters. 100 centimeters is equal to 1 meter. And I can rewrite that in terms of cubic centimeters and cubic meters if I just cube both sides. And then I get a new equation that says 100 cubed centimeters cubed is equal to 1 cubic meter. If I wanted to, I could rewrite the left side as 10 to the 6 cubic centimeters is equal to 1 cubic meter. We had to distribute out that cube to all of the terms on both sides in order for this to work. So there are 1 million cubic centimeters in 1 cubic meter. Our next step is then going to be to set up the conversion factors from the two sides of our equation. So our first conversion factor is going to be 10 to the 6 centimeters cubed per meter cubed, or it could be 1 meter cubed per 10 to the 6 cubic centimeters. Depending on what we're dealing with, we'll choose one or the other. Step 3 is then take our initial measurement and multiply by the correct conversion factor. I'm going to rewrite the measurement down here. 0.00640 grams per cubic meter. And now we need to choose the correct conversion factor. Since we want to cancel out cubic meters and be left with cubic centimeters in the denominator, the only possible correct conversion factor is going to be this one. So let's multiply by that conversion factor. 1 cubic meter divided by 10 to the 6 cubic centimeters. And then we just simplify our numbers, units. We're going to get 0.00640 divided by 10 to the 6, and our units left are going to be, well, meters cancels meters, so our units are going to be grams per cubic centimeter. And we can plug those numbers into a calculator. 0.00640 divided by 10 to the 6 is equal to 6.4 times 10 to the minus 9 grams per cubic centimeter. Last thing we need to do is check significant digits. Our original measurement had 3 sig figs. It's all the way up here. 1, 2, 3, 640. So our final measurement has to also have 3 sig figs. So when we write down our final answer, it's going to be written as 6.4. We need an additional sig fig, 0 times 10 to the minus 9 grams per cubic centimeter. And there's our new density. It should make sense that it's a smaller number. If you can fit a certain amount of grams in a cubic meter, you should be able to fit fewer grams in a cubic centimeter. So it should be a smaller number for this unit. There's method 1. Let's look at method 2. In method 2, we're going to convert 1360 watts per square meter to watts per square kilometer. And in this method, we're just going to use a single linear conversion factor twice. So let's figure out what units we're converting. we're only going to be converting those meters squared into the kilometers squared. So let's set up a conversion factor for meters to kilometers. We know 1 kilometer is equal to 10 to the 3 meters. So our conversion factors will be either 1 kilometer per 10 to the 3 meters, or it's going to be 10 to the 3 meters per kilometer. And those are our possible conversion factors. Now let's write down our original measurement. But I'm going to write it not with these negative exponents. I'm going to write down our measurement as 1360 watts, and I'm going to write it as divided by square meters. And then we multiply by a conversion factor. Since we want to cancel out the meters in the denominator, we need meters in the numerator on our conversion factor, so that's going to be this conversion factor. So let's multiply by that. We get 10 to the 3 meters per kilometer. And if we look at what we have left with our units, that's we have meters divided by meters squared. So one of those meters is going to cancel, but not both of them. We need another conversion factor if we want to cancel out that other unit of meters. So we have to multiply again. 10 to the 3 meters per kilometer. Now, this second meters cancels the second meters in the denominator, and we are left with watts per square kilometer. So now we're almost done. We just need to multiply out 1360 times 10 to the 3 times 10 to the 3. And our units left are, we have watts on top, and we have kilometers, 2 kilometers on the bottom, so that's kilometers squared. When we multiply it out, we get 1360 times 10 to the 6, which is the same as 1.36 times 10 to the 9 watts per square kilometer. And we need to check if our answer has the same sig figs. Our original answer had, our original quantity had 3 sig figs. Our new quantity has 3 sig figs, so we are to the correct number of sig figs. That is correct. Just to check for reasonableness, if we can fit 1,360 watts of power in a square meter, we should be able to fit a lot more watts in a square kilometer. So we do get a bigger number. This does make sense. It passed the reasonability check. Those are 2 methods for converting with squared and cubed units, either finding a squared or cubed conversion factor or repeated use of a linear conversion factor. Hope this is helpful. Bye.